Imagine for a second that you could hand someone a stack of books.
Okay.
And not just a few paperbacks. I'm talking about a stack containing 7 million words. Or maybe a hard drive with 107 hours of continuous audio. Or, and let's get even more specific for the developers listening today, an entire massive repository of spaghetti code that no one has dared to touch in 3 years.
Yeah, that last one sounds like a total nightmare scenario for most engineers I know.
It really does. But then imagine you could ask that person a really specific, tiny question about one detail hidden somewhere in that mountain of information, a literal needle in a haystack, and they could answer you instantly with near perfect accuracy.
I mean, it sounds like science fiction. Or at least it sounds like something that would require, a massive server farm, weeks of indexing, a whole team of data scientists set up, not just a simple chat interface.
Exactly. But according to the stack of papers we are unpacking today, that is the reality we are looking at right now. Welcome back to the deep dive. Today, we are tearing into the technical report on Gemini 1.5. Specifically, we're looking at the Pro and the new Flash models. And look, we cover a lot of AI news here, but the numbers in this report suggest we aren't just looking at an incremental update.
No, this feels very different. We often talk about models getting smarter or faster, but what we're seeing here is a fundamental shift in capacity. We are looking at a generational leap in what is called long context understanding.
Right.
We're moving from models that can read a few articles to models that can digest entire libraries, movies, or code bases in a single prompt.
Generational leap is a pretty heavy phrase to throw around, but I have to admit, when I saw the data on the Kalamang language experiment, which we will absolutely get to because it completely broke my brain, I started to see why you'd use that language. But let's ground this first. We need to talk about the headline feature here, the context window.
Right, the context window. This is the metric that really matters right now. To understand why Gemini 1.5 is a big deal, you have to understand this concept. In AI architecture, the context window is essentially the model's working memory.
Okay.
It's how much information the model can hold in its head at one time while it is processing your request.
So just to be clear for everyone, we aren't talking about what the model learned during its training months ago. We are talking about what I can paste into the chat box right now.
Precisely. It's the difference between long-term memory, so everything it learned from scraping the internet, and short-term focus, which is what you're working on right now. And for a long time, this was the main bottleneck. Previous state-of-the-art models were boasting about context windows of maybe 128,000 tokens, or I think Claude 3 was hitting 200,000.
And just for clarity, because we get this question a lot, a token isn't exactly a word, right?
Good catch, yeah. No, a token is a chunk of information. In English text, 1,000 tokens is roughly 750 words, so 200,000 tokens is a lot. It's a very thick novel. But Gemini 1.5 Pro is pushing this to 10 million tokens.
10 million. I can say the number, but I'm having a really hard time visualizing what that actually looks like.
Yeah.
If I'm a user, what does 10 million tokens actually feel like?
The report breaks it down, and the scale is staggering. In pure text, 10 million tokens is equivalent to about 7 million words. To give you a literary benchmark, War and Peace, the standard for a long, dense book, is about 580,000 words.
Wow.
So you could feed the model War and Peace more than 10 times over in a single prompt.
That is a lot of Tolstoy. But I mean, most of us aren't analyzing 19th century Russian literature on a daily basis. What about other formats?
Well, because Gemini is multimodal, meaning it treats video and audio as native inputs, not just text. The 10 million tokens translates to other formats really well. It's roughly 10.5 hours of video, or almost 5 days. That's 107 hours of continuous audio.
5 days of audio. So hypothetically, I could feed it every Zoom meeting I had for the entire quarter and ask it, hey, when did I agree to that deadline I completely missed?
Theoretically, yes.
Yeah.
You wouldn't even need to transcribe them first. You just dump the raw audio files right into the context window.
That sounds incredibly useful, but also, isn't it prone to error? I mean, if I read 7 million words, I'm going to forget the first sentence by the time I finish. How do we know the model isn't just hallucinating or skimming the data?
That is the critical question. In the industry, we test this with something called the needle-in-a-haystack evaluation.
I love this test because it's just so literal.
It really is. They take a massive data set, the haystack, and they insert a tiny, specific, unrelated piece of information, the needle somewhere deep inside it. In this report, they used a phrase like, the special magic city number is, followed by a random number. They hid this in massive blocks of text, they hid it in long audio files, and they hid it in hours of video.
And then they just ask the model, what's the magic number?
Exactly. And here is where the competitors usually struggle. As the context gets longer, typically, performance drops. The model gets lost in the middle. It might remember the beginning and the end, but the middle gets really fuzzy. But Gemini 1.5 Pro, at the full 10 million token limit, it achieved greater than 99% recall.
99%, so it's effectively perfect.
For single-factor retrieval, yes. It didn't just find the text, it found specific moments in video and audio clips. The report compares this to GPT-4 Turbo and Claude 3, at least the versions available at the time of the report, which were capped at much lower limits. Gemini is playing in a completely different weight class here. It's the difference between memorizing a pamphlet and memorizing a research library.
Okay, so it has a massive memory, but memory is useless if you can't reason with it. And this is where the multimodal part gets really interesting to me. You mentioned it sees and hears, but is it really seeing? Or is there some trick where it converts the video to text in the background and just reads the script?
That's a common shortcut in older models, yeah. But no, Gemini 1.5 is natively multimodal. It is processing the raw audio waveforms and the video frames as tokens, just like it processes words.
The report had this great example about a Buster Keaton movie, Sherlock Jr. It's a silent film from 1924.
Right, they fed the model the entire 45-minute movie. That's roughly 684,000 tokens worth of video data.
And they didn't just ask a text question. They showed the model a crude, hand-drawn sketch, like a stick figure drawing almost of a specific scene, and said, "Find this."
This is what blew me away. The model successfully retrieved the exact timestamp. It matched the visual information in the sketchy drawing to the visual information in the raw video file. It understood the concept of the scene, not just doing pixel matching.
Yeah, and there was another one where they asked about a piece of paper removed from a pocket. The model found the scene, zoomed in on the paper, which turned out to be a pawn ticket, and read the text on the ticket from a 1924 silent film.
It's wild. They also did this with Les Miserables.
All right.
They fed the entire 1382-page text of Les Miserables into the model. Then they gave it a crude, hand-drawn sketch of a character holding candlesticks. The model was able to identify the scene and locate the exact page number. Think about the implications of that for data processing.
It's huge.
Historically, if you wanted to search through thousands of hours of video archives or security footage, you had to tag everything manually. Or you had to run really expensive transcription services that lose all the visual context. Now, you just dump the raw file into the context window and ask questions in plain English.
It feels like we're skipping an entire step in the data pipeline. We used to have extract, transform, load just to get data ready for AI. Now the AI just eats the raw data.
Exactly. It democratizes the analysis of unstructured data. You don't need a data engineer anymore. You just need the file.
Speaking of skipping steps, I want to pivot to what I think is the most mind-bending insight from this whole report, the Kalamang experiment. When I read this section, I actually had to stop and reread it because I thought I misunderstood.
You and me both. This is probably the most scientifically significant part of the report because it tests a concept called in-context learning.
Okay, set the scene for us. What is Kalamang?
Kalamang is a Papuan language. It has fewer than 200 speakers worldwide. Crucially, it has virtually no internet presence.
Which matters because
it means the model couldn't have memorized the language during its initial training. If you ask a standard model to speak French, it knows French because it read the whole internet. But Kalamang is effectively an alien language to the AI. It has never seen it before.
So how do you teach an AI a new language that isn't on the internet? Usually you'd have to retrain the model, right? Spend millions of dollars, weeks of compute time.
That's the old way. In this experiment, they utilized that massive context window. They took a 500-page grammar book, a dictionary with 2,000 entries, and about 400 parallel sentences. Those are sentences translated between English and Kalamang. They uploaded all of that right into the prompt. It was roughly 250,000 tokens.
They basically shoved a linguistics textbook into the chat window and said, okay, you have the manual now. Translate this.
Essentially, yes. They asked it to translate English into Kalamang, and the result was stunning. Gemini 1.5 Pro learned to translate at a level similar to a human who had been learning from the same materials.
Just from the prompt, no training run.
Zero training updates. It's what we call in-context learning. It held the rules of the language in its working memory and applied them dynamically.
And there was a twist with audio here too, right?
Yes. They added 45 minutes of Kalamang audio recordings to the context stack. The model actually began to learn to transcribe the spoken language just by listening to those clips and cross-referencing them with the grammar book it had read. It connected the sounds to the rules.
This feels like a massive shift. It implies that the model can learn new skills at runtime. You don't have to send it back to the factory to learn a new coding language or proprietary legal framework. You just paste the documentation in and say, use this.
It completely blurs the line between training a model and just using a model. For businesses, this is huge. You don't need to fine-tune a model on your company's internal wiki anymore. You just put the wiki in the context window.
But I have to play devil's advocate here for a second. Processing 10 million tokens, reading grammar books, watching movies that sounds computationally expensive. Is this thing going to be slow as molasses? If I ask it a question, do I have to wait an hour for an answer?
That is the billion-dollar question.
Yeah.
The report discusses the architecture, and this is where they reveal that Gemini 1.5 is built on a MoE architecture, mixture of experts.
Okay, lay it on me. What is mixture of experts?
Think about your brain. Imagine if every time you had a single thought, your entire brain had to light up every single neuron. That would be exhausting and incredibly slow. Mixture of experts is like having specialized reasons. When a query comes in, the model doesn't activate the whole massive neural network. It uses a routing mechanism to send the input to specific expert pathways that are best suited for that specific task.
So if I ask about coding, it wakes up the coding neurons, but lets the poetry neurons stay asleep.
That's a great analogy. It makes the model much more efficient because it's doing less work for each token it generates. And this efficiency is what allows them to introduce a new version of the model called Gemini 1.5 Flash.
Flash. I assume the name implies speed.
It does. Flash is a lighter, faster model designed for high-volume tasks and lower latency. But here's the kicker. Despite being the light version, the report says it matches or beats the previous generation's top model, Gemini 1.0 Ultra, on many benchmarks.
That is really impressive progress. The elite version now beats the heavy version from just a few months ago.
Exactly. And they even mention a Flash 8B variant, which is an extremely small version that still supports that massive context window. This could be a huge deal for tasks like data labeling, where you need to process tons of information cheaply and quickly.
And the report specifically calls out coding for these models. I know a lot of developers listen to this deep dive. How good is it, really?
It's very strong. In one example, they fed the model the entire JAX codebase. It's a complex machine learning library, and it's about 746,000 tokens. The model could answer specific questions about implementation details by looking at the whole repository at once.
That is the dream. Usually, you have to rely on snippets or search. But if the model can see the dependency tree and the definitions across different files simultaneously...
It's like having a senior developer sitting next to you who has memorized every single line of code in the project. But it's not just memory, it's reasoning. The report highlights improvements in agentic capabilities.
Agentic meaning acting like an agent, doing things.
Yes, planning, multi-step problem solving, things like planning a trip or scheduling meetings. Gemini 1.5 showed strong improvements here. You can look at a calendar, look at a request, and figure out the logical steps to make it happen without human hand-holding.
Speaking of logic, we have to talk about math. I was terrible at math in high school, so this appeals to me. There's a math specialized version mentioned in there.
Yes. They fine-tuned a version of Pro specifically for math, and it achieved 91.1% on the math benchmark. That is a data set of competition-level mathematics problems.
Is 91% good compared to a human?
It rivals human experts. And significantly, it solves complex theorems without using external tools. It's not just using a calculator plugin or running Python code to cheat. It is using pure reasoning, chain of thought, to derive the answer.
Okay, so we have a model that can memorize movies, learn languages from a book, code like a wizard, and solve complex math. But is it safe? Because usually, when things get this powerful, they get a lot harder to control.
That is the responsible question to ask. The report dedicates a significant section to safety and reality checks.
Okay.
They did extensive red teaming.
That's where they hire hackers and experts to try and break the model, right? Try to make it say bad things.
Exactly. They found that the model is much better at refusing harmful queries, things like hate speech or dangerous instructions, while still remaining helpful on safe topics. It had a significant reduction in policy violations compared to Gemini 1.0 Ultra.
But let's be real, it's not perfect. You mentioned earlier the needle-in-a-haystack test was 99% successful. Is there a catch?
There is a nuance there. The single needle test is great, but they also ran a multiple needles challenge. Imagine asking the model to find not just one fact, but 100 different facts scattered throughout that massive 10 million token window.
That sounds much harder. That requires maintaining focus on multiple threads simultaneously.
It is, and the performance does dip slightly as you approach the limit in these complex retrieval scenarios. It performed well better than GPT-4 Turbo, according to the report, but it shows that it's not magic. If you overload it with complex, scattered retrieval tasks, it can still miss things.
That's a really good reality check. It's a tool, not a deity. It can still get overwhelmed if you ask it to juggle too many balls at once.
Exactly. And we should also mention that while the context is massive, the reasoning capability over that context is still bounded by the model's intelligence. It can read a physics textbook, but that doesn't mean it can invent new physics.
Right. It's a super reader, not necessarily a super scientist. So let's bring this all home. We've covered a lot of ground today. If you had to distill this report into the key takeaways for someone listening, what are the 3 pillars?
For me, pillar 1 is the context window. The 10 million token limit changes the game for data ingestion. You don't have to curate and chop up your data anymore. The data pipeline is shrinking.
You just dump the haystack in and ask the robot to find the needle?
Precisely. Pillar 2 is native multimodality. It's not translating video to text, it's seeing and hearing as a primary sense. That opens up video and audio archives in a way we just haven't seen before.
And pillar 3?
It has to be in-context learning, the Kalamang experiment. The idea that the model can learn a new skill, a language, a coding library, a company policy, just by reading the manual and the prompt.
That feels like the most disruptive part to me. It shifts the value proposition from what does the AI know to what can the AI learn right now?
That's a profound shift. It moves from static knowledge, what it learned during training, to dynamic understanding. It allows for a customized expert on demand.
It really feels like the barrier to entry for highly specialized AI just dropped through the floor. You don't need a machine learning team anymore. You just need a really good PDF.
And a very long prompt.
Definitely. I want to leave you with a thought that popped into my head while reading about the library of books Gemini can hold in its memory. We always talk about AI as something that knows everything because it was trained on the whole internet. But with this long context ability, are we moving toward an AI that maybe knows less upfront, but can learn anything instantly?
I think that is exactly where we're heading. And honestly, an AI that can read your specific data and understand your specific context is infinitely more valuable than an AI that just knows general trivia.
From a trivia bot to a quick study genius. I like that. Make sure to check the show notes. We will link to some of the Kalamang translation examples from the report because seeing it in action is really something else. Thanks for diving in with us.
Always a pleasure.
See you next time on The Deep Dive.